Hello friend, today we are going to discuss about Kubernetes. It's a new chapter and we are introducing in this video about Kubernetes. In this video we will see that what is Kubernetes and what is the architecture and process of Kubernetes and what is the features of the Kubernetes. So let's begin. Firstly we know what is Kubernetes. Kubernetes is an open source container management tool which known as a orchestration tool also. We can say that it is a orchestration tool which known as a also container management tool which automate container deployment, container scaling and descaling and load balancing. Kubernetes is a open source container management tool means we can use to manage our container through this Kubernetes, and it is a open source tool which automates container deployment, container descaling and scaling. In the both time we can use Kubernetes. Suppose we are using 100 containers, so we can scale it, and after that if we not need 200 containers, so after that we can descale, and we can also manage their resource also and load balancing. It schedules, run and manage isolated containers which are running on virtual, physical and cloud machines. Means Kubernetes can be managed in the virtual machine, physical machine and cloud machine. And it can be scheduled, run and manage isolated containers. Let's know about history of Kubernetes. Google developed an internal system called Borg, later named as a Omega, to deploy and manage thousands Google's application and service on their cluster. Actually, Kubernetes developed by Google. Firstly, when it's come in the market, so it developed by for their internal system where they can manage their services and application on their clustering of container tool. But after some time in 2014, Google introduced Kubernetes, an open source platform which written in Golang language and later donated to CNCF. It is a foundation where Google has Kubernetes to means hand over and donated to further managed to CNCF, which is a foundation which manage right now Kubernetes. So it is a Kubernetes. So let's move on the architecture of Kubernetes. We have already discussed about that what is difference between Kubernetes and Docker Swarm. Actually, both tool is used to manage the container. If we are using 1 to 10 containers, so we can manage manually. But if you have to use 100,000 containers, so we can't manage manually. So in that case, we need Kubernetes and Docker Swarm. So Docker Swarm is a inbuilt tool which is made and developed by Docker. But Kubernetes is a third party tool which is supportable for even Docker or Rocket container base also. Means if you have any other platform of container, so you can use in the Kubernetes. It's a familiar with another platform also. But Docker Swarm is made for Docker only. It cannot be used any other containerized tool. So Kubernetes is a good and very popular, and you can say that 90% is market share of the Kubernetes, and almost 90% company provide the certification of the Kubernetes, and it is most popular use in the Kubernetes. So let's move on the architecture of the Kubernetes. This is our architecture of Kubernetes, where you can see that one part of our is server and controller. We can see here that is a part of our server, and second part we have taken here two nodes. One is node 1 and second is node 2. Actually, when we use Kubernetes, all these things will be managed by API server. Means everything whatever you have to do, you have to call to API server, and then it will distribute their work according to their requirement. So once, whenever you can see here, that's a sign of the Kubernetes. If kubelet has to talk anything about any controller, any scheduler, so firstly it will go to API, and API will move and forward to controller manager and scheduler if scheduler is required. So in this thing we are using two parts. One is a server and second is a slab. You can say the server and slab, server and clients, server and nodes. So we have a server part here where API is very important. Whatever the process will be done by API, API is a main part. You can say that it's a wall of control and server, where if server have to talk to client and node, so it will use to API server. And if node have to talk with their controller manager, their scheduler, so they will have to come firstly to API, and then API will be forward. You can see that when node want to connect anything, so that data will go to API, and API server to forward according to their requirement. And any API, and if controller need to want to talk with scheduler, so firstly it will go API, and API will forward to scheduler. So in that case it's thing happen. Let's move on that what is the component of this Kubernetes architecture we are using. You can see here two parts. One is a server part where we are using API server, which is used to connectivity. You can say that from server part and node part. And second is a cloud controller manager. It is a optional when we have our container and containerization tool is on hosted on cloud controller, so we use at that time cloud controller manager, where all the manager managing things that you have to create how many replica, you have to create how many container, you have to create how many pod, you have to put the name of the pod, container name. So it will be managed by the cloud container if you are using on the cloud hosting. If you are using on normal, you can say virtualization and anything except the cloud controller, so you can use controller manager. The both work are same. It is a main part of the controller manager, means everything will be managed by the controller manager. Okay, it work on desire based solution, means suppose if you have to take two fruits, so desire will check that yes he need two fruits, so he will put and he will give you two fruits. If he need four container, so it will provide you four container as a replica. If three, so if three, whether any container will be fault, damage, anything crash, so desire it will create automatically our another container very fast. And etcd is a very important part. It is a persistence store, means it keeps all your information about every version, every things in their storage. And whenever, suppose in that, why do we use etcd? It is used when suppose you have created one pod and you have created two container, so one container will be down, so what will be done? How can client will check, node will check, and controller will check that two container is there or not? Suppose it will check that there is a two container or not. Kubelet. Kubelet is used to check that it is a agent application which is run on the node system, and which is used to check that your pods and container are running fine or not. If anything will be crashed, fault, damage, so it will move information about the API server that one container is down. So it will go and check that how many container and we have assigned that. So it will go on the ATC container controller manager, and it will check that we have allotted 4 container but one container is down, so it will go and scheduler. In that case all these thing will be run and it will provide the, it will create instantly another container in the different name, and it exists container which was crashed that will be deleted automatically. And scheduler is basically check that any updates, any can say, you can say that all the information about updates comes will come scheduler. If any schedule have will be happen just like a 4 cluster you need to be created in one port, yeah, 4 port be created in the one node, so it will scheduler will be work there. Kubelet is a very important part of the agent. It is a agent based tool which is run on node based application, on node system, and it will check that whatever you have given controller manager through command to that how many container is running and all the container are running on node, so it will check and give the information to API server, and API will forward their concern to controller manager, and all the process will be executed one by one. And kube proxy is used for networking purpose, that what IP will be assigned, what network, and all these things related to networking that will be managed by the kube proxy. And it is mandatory that if you have a 2 and 3 nodes, suppose we are using here 2 nodes, so one node is, we have a kubelet and proxy. So in same thing we have another node, node 2, there is also a kubelet and kube proxy, and we have installed docker. And it is main part that kubernetes does not talk container directly, it is used port based solution. Port is things that will be talked to container. Why port is created by the kubernetes? Because kubernetes the have a solution multiple containerization tool. It has a solution. Suppose right now we you are using in your organization docker, but in another company they are using rocket container. So in that case kubernetes have to make their, you can say that solution that they have to talk directly to container, docker and rocket. That's why it's create port, and port talk with their container, whether any you are using docker container or rocket container. So it's a whole architecture and process of the kubernetes. I think it is very important, you need to be know about all these things. This is very important, you must be know all these things. Let's move on the features of kubernetes. What is the features of Kubernetes? Orchestration, clustering of any number of containers running on different network. It is an orchestration tool where if you are using clustering of any number container running on different network, that can be managed and used by the orchestration tool. Auto scaling. Auto scaling means if you need 2 GB RAM and 3 GB RAM, and after some time it will be need 4, 5, 8, 10 GB RAM, so it will be auto scale, and it will be work on the number of containing based also. Means it work on horizontal and vertical also. Horizontal and vertical means suppose you need to upgrade their RAM, so it will automatic auto scaling and they will upgrade their RAM from their Docker engine. And if they need one container and after some time you can see that their traffic and load is higher which is not managed by one container, so it will create automatically second container, and traffic will be moved on second container also, so it will be work on horizontal and vertical auto scaling also. Auto healing is a very important part, that when container is running or not, if any container will be crashed, means any port will be crashed, so what will be done, it will create another port as soon as possible, and it will check that if any container, if any port will be damaged, so it will create soon another another container and ports in the replacement of that. Load balancing. In the load balancing, suppose if you are using three ports and you have used one container in each ports, and your one container is three container and three ports are not able to manage all the traffic, so it will automatically load balance. It will create multiple container ports and the traffic will be moved one to by another sequentially. It will use, you can say that they will traffic manage and they will balance the load of every container. Platform independence. Kubernetes can be used in cloud platform, virtual platform, and physical platform. You can use anywhere Kubernetes in their platform. That's why it is a platform independent. Fault tolerance, node port failure. Suppose if you are using 10 nodes and your 2 and 3 nodes will be crash, so it will give you fault tolerance, means it will create another port, and if your one node is totally down, so it will create multiple node automatically. That's why it's provide the fault tolerance. Rollback features, going back to previous version. Suppose you have updated some features on their container, so what happened in that case? Your container, your pro services is not working properly, so you can go back on your previous version. So it has a rollback features also. Health monitoring of containers. It has a feature that it can monitor of your containers. It has a GUI interface where you can monitor of all the container, that what container are using, how many container resources using, which resource are using higher in the container, whatever. You can check and monitor according to your requirement. Batch execution, one time sequential parallel. You can batch execute also, whether you want to use one time sequential and parallel also in Kubernetes. These are the features of the Kubernetes. You must be know about all these things, and it is a very important for Kubernetes before moving on the advanced level. I hope this video is helpful for you. So please subscribe our channel and hit the bell icon to get more updates first. Thanks for watching.